This is Captain Ross with 3B's Captain School, and this video is on emergency procedures in our deck video series. This is emergency procedures in our deck video series. So our objectives for emergency procedures: we want to state responsibilities of the captain master in an emergency situation, state general elements of a float plan, state emergency procedures for a man overboard, describe the approaches to a person in the water, state required condition, stowage, and accessibility of life-saving equipment, state procedures for abandoning ship, and describe practices for survival at sea. All right, as the captain master of a vessel, you are ultimately responsible for passenger and crew safety. It is your responsibility to ensure that the vessel is seaworthy and outfitted as required with emergency equipment. You are also responsible for your crew's training and drills and actions in an emergency at sea. All right, a float plan. A float plan is an essential part of any voyage and should be communicated to a responsible party, such as the marina you're leaving from, an agent, prior to any voyage. Every float plan should include your destination, your vessel's description, general safety equipment aboard, your return estimated time of arrival, names of the crew, number of passengers and crew, alternate destinations, and your communications equipment. Man overboard. A man overboard is a very serious emergency, and every captain crew must be prepared to act immediately to safely recover the person from the water as quickly as possible. If a passenger or crew member goes overboard, first thing you want to do is the first person to see or realize someone has fallen overboard should sound the alarm by shouting "man overboard" and identifying the side if they know which side the person went overboard on. It's critical too that the person who saw or realized that someone went overboard, they see him in the water, maintain sight of the person until they are recovered. If possible, another crew member will throw a life ring towards the person in the water. The life ring provides flotation for the man overboard or person in the water and gives a last known position in case the person is not immediately recovered. So by putting that life ring in the water, you're establishing what's referred to as a datum or datum. And the datum is the most likely position of that person or search object corrected for set and drift. So as that life ring floats in the water, it's going to drift in the same general direction as the person would drift. So it allows you to adjust your search patterns as you're looking for the person if you don't recover them immediately. Upon hearing man overboard, the captain should, one, as quickly as possible, turn the vessel towards the man overboard. Turning towards the MOB moves the propellers away. So as soon as you hear man overboard port side, you want to turn hard to port, which kicks your propellers away from the person in the water. You want to hit the man overboard or save button on your chart plotter or GPS. Determine the best approach and recover the man overboard as quickly as possible. If the man overboard is not immediately recovered, call the U.S. Coast Guard and other vessels for assistance. Issue a mayday call. So let's talk about approaches. So as the master, you're going to make the approach to the person in the water. And this approach is going to depend on the existing conditions, wind, seas, current, and your vessel's handling characteristics. So there's two basic ways to approach: a windward approach with the bow into the wind and seas, or a leeward approach with the stern into the wind and seas. You want to practice this with your crew. Use a life ring or something to simulate a person in the water and practice a few times in different weather conditions so you get an idea of how your boat responds and how it responds in different weather conditions. So if you have a person in the water, you're not scrambling to determine what's the best approach. You'll kind of have an idea already from practicing. All right, so in addition to that leeward or windward decision, you must decide the best technique for maneuvering the vessel into position to make the approach. One of the ways you can do this is to stop immediately. There may be incidences when stopping the boat and allowing the person overboard to swim back to the boat or at least reach the tethered floating object, a life ring or something, is the most appropriate action. You can also stop, pivot, and then return to the position, which is another option. It's particularly good in a restricted waterway. The turning and backing characteristics of the boat and the prevailing wind and sea conditions will dictate exactly how you make that approach. So let's look at a couple of approaches. The destroyer turn. So in the destroyer turn, you want to put your helm all the way to port, and when the stern is well clear of the man overboard, approximately 2/3 of the way into the turn, you want to back down the port engine to quickly complete the turn. So this is done with a twin screw vessel. You can't really do this too well with a single screw, and it's especially effective in narrow channels or waterways. So again, you turn the helm, and you can turn the helm to port or starboard. But in this example, we're going to turn the helm to port, and then we're about 2/3 of the way through and the person's completely clear of where the screws would be. We're going to back down that port engine so that we can speed up the time it takes us to spin around. If you're using a single propeller boat or a single screw, you can do this maneuver. You're just going to put the helm hard over to port and then give it some extra gas or power to help you power through that turn as quickly as possible. So we have the Anderson turn, which is another one. And this is a fast recovery technique for twin screw vessels. You put the rudder over full in the direction the person went overboard on, and then increase power on the outboard engine only. When you're about 2/3 of the way around, you want to back down on the inboard engine. And if you can, you want to back 2/3 or full. You want to give it quite a bit of power on that inboard engine astern. And then you want to stop the engines when the person overboard is within about 15 degrees of the bow. Ease the rudder and back the engines as required, to kind of slow your momentum there and gain the proper angle to make the final couple feet of approach up on the person to pick them up. Another technique is called the racetrack, and this is used when you need a longer straight line approach. So you put the rudder over full in the direction corresponding to the side from which the person fell and increase overall speed. Use the rudder to turn to the reciprocal of the original course. Reciprocal is 180 degrees out. So if I'm on a true north or a north course 000, then I want to use full rudder and turn until I'm at 180 degrees. And then steady up on that course for a short distance, and then use full rudder again to come back to my original course. And it basically looks like a racetrack. You make a full oval-shaped circle back to the person that fell overboard. Finally, we have a Williamson turn. And this is primarily used if an individual fell overboard during periods of darkness or restricted visibility, and the exact time of the incident is unknown. So with this one, we're going to alter our course 60 degrees to the port or starboard from the original course. It doesn't really matter which direction that you go because the person in this case has already fallen overboard previously. They're not alongside the boat any longer. If you turn to starboard, you're going to add 60 degrees to the original course. And then if you're turning port, you're going to subtract 60 degrees from your original course. So I'm going to put the rudder, let's say starboard, hard to starboard until I'm on a course that's 60 degrees to the starboard or right of my original course. I'm on 000. I'm going to come right till I'm at 060. And then as soon as I get to 060, I'm going to go hard left rudder and turn until I'm 180 degrees off my original course, which in this case would be, I started at 000, I turned right to 060. I'm going to come hard left until I'm at 180, which is 180 degrees off my original course. And what it does is it puts you right back down your wake. You'll go right down the center of where your boat was running before, puts you right on track, and then you follow that course back until you find the person overboard. Emergency procedures, life-saving appliance operations. So all life-saving equipment must be in serviceable condition and either readily accessible or immediately available, depending on the equipment. And those terms will be used if you refer back to the deck lesson on UPV rules and regulations. it describes and uses those terms readily accessible or immediately available with all of the life-saving equipment, life rings, life jackets, fire extinguishers, and such. It's the captain's responsibility to outfit the vessel with the required equipment, and we go over that required equipment for uninspected passenger vessels in that UPV rules and regulations lesson. It's also the captain's responsibility to make sure that equipment is properly stowed and in serviceable condition. In addition to ensuring that all life-saving equipment is on board and serviceable, the captain is also responsible for briefing passengers on the following items prior to getting underway. The stowage locations, you need to tell everybody where the life jackets are stowed. Proper method of donning and adjusting the life jackets or life preservers carried on board the vessel. And the type and location of all life-saving devices, life rings, life floats, life rafts, that kind of equipment. Abandoned ship. Abandoned ship procedures. Abandoning ship is extremely hazardous and should be done only when absolutely necessary. This is another responsibility of the captain or master. You're the one that's going to make the call when to abandon ship. So make sure that the conditions and danger on board, you have a fire and the whole engine room's completely in flames, or the cabin's in flames, or you're taking on water and you're not going to be able to pump out the water that's on board or minimize the water coming in to maintain stability. And you're going to put everyone in abandoned ship. So what we do with abandoned ship: transmit a mayday as soon as it's apparent the vessel has an emergency severe enough that you may have to abandon ship. Have all passengers and crew don or put on their life jackets and any clothes that will help protect them from the elements without weighing them down. You also want to make sure everybody stays above deck at this point, so you don't want anybody going below deck for anything. Have the crew at the ready to launch the life rafts. Collect all signaling equipment, emergency provisions, and place it in a ditch bag. Or better yet, you can kind of disperse that equipment amongst your crew. So if you have multiple life rafts that everybody's getting in, you want to disperse the signaling equipment so everybody has something to signal help with. Launch the life raft, ensuring that it is tethered to the vessel, and you want to launch it on the leeward side of the vessel. Activate your EPIRB and make sure it's attached to the life raft. You only want to use signal flares if you're in sight of land or other vessels. If the vessel begins to sink after everybody's in the life raft and you abandon ship, capsize or is on fire, you want to cut the tether line that's tying the life raft to the boat before it sinks or burns. And then if the vessel stays on the surface, like if it capsizes and the hull's on the surface, you want to stay as safe or as close to that as you can while still being safe. So the vessel stays on the surface, like it capsizes and you can still see the hull in the water. You want to stay as close as possible with your life rafts to it, because what you're trying to do is create the largest object in the water that someone can see, the largest visual cues that there's been an emergency. So if you have search aircraft or something, they can see potentially the life rafts, or they may see the hull of the sunken boat or the boat on fire, the smoke and everything, and that'll attract them to your life rafts. All right, survival at sea. So we went ahead with that abandoned ship, and now we're all in the ocean. So the first thing to remember is survival at sea is highly dependent on preparation and a person's determination. The length of time a person can stay alive in cold water depends on the temperature of the water, the physical condition of the survivor, and the action taken by the survivor. So initial action, hopefully everybody's outfitted in life jackets and anti-exposure coveralls if you're in cold water. If you look at this graph here, it gives you an idea of how long someone can last in different water temperatures. So I'm going to take my cursor here and kind of follow along. So 32 degree water or 0 degrees Celsius, you can see that the average time here is about 1 hour. 41 degrees, you're almost at what, 1 hour, 45 minutes. 50 degree water, you're talking 2.5, 3 hours that you could potentially last. And people who lose body heat quickly aren't going to last as long, and people who lose body heat more slowly are going to last longer. So some skills that we can use to increase our survival if we're in the water. Immediately upon entering the water, try to locate the sinking boat, try to board a life raft, a lifeboat, overturned boat, or other floating object. And what we're trying to do here is just get out of the water. And so if a boat capsizes and we can still see the hull, we want to climb up on the bottom of the hull. One, remember the hull is going to be more visible to rescuers than just a person in the water. And you lose body heat much quicker in the water than you do when you're dry. I think it's 25 times quicker when you're submerged in water. Don't attempt to swim unless it's absolutely necessary. You want to float as still as possible in what we call the help position. And that's in this diagram here. And the help is the heat escape lessening position. And you're basically going to pull your knees up and put your arms across your chest. You're trying to maintain as much heat as you can there where your heart and lungs are at. If possible, you want to huddle with other people in the water just to kind of share some of that body heat. Avoid drown proofing. If you remember, drown proofing is where you lay on your stomach with your face in the water and you just kick your head up every time you take a breath because you don't want to put your head in water as much as possible. You have to maintain a positive attitude about your chances for rescue. Remember, a will to live does make a difference. All right, emergency procedures, towing. We're going to cover emergency towing. Emergency towing should only be undertaken by captains that have experienced towing other vessels or are confident in their ability to safely connect the tow and maneuver with a vessel in tow. Below is a list of suggested steps, procedures, and precautions. So first, you want to evaluate the weather, the disabled vessel's condition, your vessel's equipment, position, the distance and route to the nearest safe haven. These all go into the decision of whether you take another vessel in tow. Remember, you only want to tow another vessel if it's safer than not towing. Develop a plan with your crew and the disabled vessel, and you want to maintain communications throughout the tow with the disabled vessel. So you got to make sure they have a radio and that you've established some hand signals in case there's communication problems with the radio, so they can communicate back to you if there's a problem. Start the tow slowly to minimize stress on the gear and maintain a slow tow speed throughout. Make sure the disabled vessel is in step. And in step is a term we use if you're in any kind of seas. You want your vessel and the vessel you're towing to be in the same position on the wave. So if you're going up a wave, you want that towed vessel to go up a wave. If you're going down a wave, you want the towed vessel going down a wave. And that keeps you from shock loading the lines, the tow line. Tow the disabled vessel to the nearest safe haven. If taking the disabled vessel in side tow, which you're normally going to do before you take them in to a dock and try to tie them off to a dock, you want to make sure your vessel's stern is behind or aft the other vessel's stern. Otherwise, the other vessel's rudder and props and everything will kind of disturb the water that your vessel's rudders are trying to use to control your boat. So it makes it much harder to control both boats when inside tow if the towing vessel's stern isn't behind the towed vessel's stern. This concludes our video on emergency procedures and our deck video series. Please check our YouTube channel for our other videos.